Hey, year 12, thanks for coming, guys. There you go, it's already there, look at that. I'll post the link to the YouTube video onto the Google Hangout as well. There you go, that's in there now. I'm live. Epicote, I think that's Oliver. Oliver's there. Bonjour. That's French for hello. I'm gonna move my YouTube video over to here. There we go. Hey, it's up and running. There we go. Sian's in, Didney's in, don't know who Didney is, whatever. Pop out chat, and then I'll get rid of that one because I know it's working okay. If there's a problem with the sound, by the way, I did have a minor problem with the sound because I have to, it's just, they're cheap cables. So when I move the tablet around, I often, it just goes all blurry. Assalam you, I can't say that at all. That's terrible. Didney equals Russell. Sound is fine. I know, I'm going to change my tablet to tablet mode in a second, and then it's all going to go belly up. Okay, so we're starting Redox today, guys. This is Redox Lesson 1, Oxidation States. Redox is a short topic. It's only going to be about 3 lessons. So I want you to bear that in mind because you are going to have a test at the end of this. And it's going to be a fairly brisk one. So I'll share my screen with you guys. And then I'm going to switch to that one. And then I'm going to change my camera because I've got a new webcam. So I can now switch this over to here. Boom! Check this out. Yo, yo, yo. So I can do my dancing. I can do my dancing whilst doing my writing. Obviously, you'll be watching me write most of the time. But, you know, trying to become one of these proper YouTubers now. Okay, so I'm going to switch my tablet to tablet mode. Tablet mode. Here are your learning objectives, folks. There you go. Right. Yeah, you see all the cables are now going wonky donkey. Let me know if you can still hear me okay. I've super glued my pen tip, so that has such a large field of view. I know, and I should really try and fiddle around with it. I feel like there's going to be some kind. See, I'm now getting horrible connection issues with my HDMI cable to my tablet. It's actually a really good point. That I wonder if I can do. Fiddling with this is a really bad idea. No, I don't think there's a zoom function. Nope, definitely no zoom function. I don't know if I can do that in any settings. I don't think so. It's not going to let me advanced. Nope. No. Okay, so I love the keyboard slam. Nice one. Professional streamer. Hey. That was my blue steel, by the way. Blue steel. I don't know if you guys know the film reference there. If you do, immediate commendations, if you can tell me the blue steel reference there. The large field of view is fine and kind of nice. Okay, so 3 learning objectives today, guys. I'm sorry that they're a bit long. I hate writing long learning objectives. It's a pet peeve of mine. So no standard oxidation states from the periodic table. You guys already know this. We've been doing redox. See, one of the things that you guys don't realize is that I do a lot of the topics where redox fits into other topics, I will just teach it. So a lot of this is going to be fairly brisk, and hence why the topic's going to be fairly short. So no standard oxidation states from the periodic table. Number 2, be able to use standard oxidation states to find non-standard oxidation states. Yeah, last one is understand reduction and oxidation and the rules for oxidation and recognizing oxidation and reduction. You guys already have 2 of the rules, and I'm going to give you a 3rd one today. Okay, so let's crack on, folks. Let's see how my pen holds up after I've super glued it. Okay, so first thing, subtitle is Oxidation States. Oxidation State. So oxidation state, the first thing we need to do is translate this into real words. You know, chemistry is lovely sometimes for its words because I feel like chemists have been sensible a lot of the time. Every now and again, though, it's not particularly easy to understand it. So oxidation state literally means charge on atom/ion. Now, I shouldn't actually do that, really. I should really do ion. But the problem is when it's inside a molecule, you can't really deem it as an ion specifically. Yeah, so I'm going to put atom and ion. And I'll try and clarify that when we have a look at certain questions. But the great thing is you guys have already done this. So first of all, we need to look at the periodic. So charge on an atom or ion, and we need to look at the periodic table. So you guys know, so we can actually do this in an activity, in a set of questions. So if I said to you, Sodium. If I said to you sodium, and then I said ion, question mark. So everybody now on the chat, please, let's get 6 responses. What will be the charge on a sodium ion? Go. What will be the charge on a sodium ion? I'd love to think that by this point in your chemistry education, you don't really need the periodic table for this. Well done, Oliver, straight in there. Well done, spot on, +1. Thank you. I'm wondering whether anyone else is going to follow, because I know that'd be well done. Who's Niazi? Is that a Shazza? Who's Didney's Russell? Thank you very much. Wing Kit's in there. Like it. 4 responses, 2 to go. It's nice just for me to know that you guys are still watching and you're live. Thank you, Marcellus. Good job. By the way, it's nice to mention, if you notice from the 5 responses I've got 1 plus and then +1. In reality, it makes absolutely no difference. You can do it as 1 plus or +1. You can do it however you like. I often mix between the two. Me is Shazza. I like it. Shazza's Niazi. Okay. Got 1 person who hasn't posted. Who's that going to be? Cian. Cian didn't bother to post. Thanks, Cian. Cheers. Really appreciate that. So we know that sodium is always +1. Yeah. And in reality, you guys probably pulled that from memory. And the best thing is, of course, it comes from our beautiful, wonderful periodic table. I love my periodic table. It's my favorite thing. Because all the atoms in group 1 are going to form +1 ions. Yeah. All the atoms in group 2 are going to form +2 ions. And then we get the transition metals, the TMs. Now, the TM metals vary. They vary in charge. Variable oxidation states, you learn that at GCSE. Then you learn group 3. Group 3 is +3. Yeah, group 4 is +4 or -4. But in reality, that's actually not as clear as you'd like to think. +1, sorry, I was watching it slower to write notes. Fair enough, I understand that. Okay. Now, can I just point out that that one there is actually not entirely true. So I actually don't like that one. What at that point is I'm going to put variable, V for variable. And then we tend to get -3, -2, -1, and then no charge at all for the noble gases. Not entirely true either. But can I just point out that these are what are called the standards. So if somebody asks you for a standard oxidation state, you just quote it directly off the table. So let's have a go on the chat again. What is the standard oxidation state for a chloride ion? Post on the chat, please. What is the standard oxidation state for a strontium ion? What is the standard oxidation state for an aluminium ion? What is the standard oxidation state for a phosphide ion? Thank you very much. -1 for chloride. Well done. Oh, look at this. Well done. Oliver's into the +2 for strontium. So you guys can do this already. We've been doing this now for a long time. The first time you were introduced to these standard oxidation states was in GCSE, probably now in year 9, maybe even sooner, where you start coming across these charges when the atoms become ions. Now, you learn it at GCSE in regards to the atomic structure. You look at the number of electrons in the outer shell. How many does it want to gain? How many does it want to lose? And this is how we do it. And it's great, great logic when you start building it from that perspective. Now we start to realize that these things can actually be non-standard as well. Now, there are certain things that you do just have to flat out learn. So at this stage, I can go back to my notes. And I can now go, and I'm going to actually add a couple of these. Chloride, yeah, is Cl-. Let's also add another one, a sulfide ion, as well as -2, S2-. Yeah, doesn't matter if you do -2 or 2-, it makes no difference. So at this point, I'm pretty sure that everyone in this room can do my first learning objective. If I ask you for a standard oxidation state of an element in my periodic table, you will be able to tell me it based on your knowledge of the group numbers. Nice and easy. That's straightforward. Now what we need to do is be able to use standard oxidation states to find non-standard oxidation states. So let's now push into that boundary. Let's have a look. So we can now say title is finding stroke calculating, because it is a calculation technically. Calculating non-standard standard oxy states. Now, I've been doing this with you guys for a while because I did it properly. I did this when we were talking about naming of compounds. What is the standard oxidation state of group 4? Do you say variable? It's a really good question, Oliver. So the problem with group 4 is that they won't ask you, Oliver, because it is variable. The standard would be either +4 or -4, but in reality, they just don't have it, Oliver. So that's a note to make. Let's do that. Let's make a note of this. Nota bene. Group 4 elements, like carbon elements, there we go, try that again. Group 4 elements don't have standard oxy states. Oxy states due to having half full outer energy levels. Outer energy levels. Now, there's an extension to this, which is actually far more important, because in group 4, you would have to become a +4 or a -4. That would mean removing 4 electrons or gaining 4. That's just basically impossible. So which means they not only do they have a half full outer energy level, but in reality, what's a better explanation is the fact that they're going to be covalent. Yet these things aren't going to be ionic. You don't find, you can find carbides, but the carbides aren't going to be ionic. They're going to be covalent. Group 4 elements will not really, form ionic compounds. Yet they're going to be covalent. They will be covalent. Yeah. So that's the little nota bene. That's actually a far better, because once you become +4, you're going to become such a high charge density that you're going to have distortions all over the place, which are going to force you into becoming covalent anyway. So it doesn't really matter. And you guys having covered bonding now should understand polarization of ions and polarization of atoms, and be able to probably link that to that. So, okay, so I've been doing this with you guys for a while now. So this is, again, another activity. So let's now do sodium chlorate. So my question now is, what is the oxy state of Cl? Question mark. So off you go, guys, on the chat, as soon as you've figured it out. What is the oxidation state for chlorine in that particular compound? Well done. Well, John, I love that. Now, isn't that interesting? So I've got Russell and Shazza giving me the opposite answers. So one of them's got to be incorrect. There we go. We've got Oliver now supporting Shazza, Sian supporting Shazza. Now, can I just now please say, don't, and I know it, when you guys start, oh, typo. Can I please say, don't rush this process? When students get good at this, they speed up. When they speed up, they make errors. And so let's now show the process. Can I just point out, I don't guess any of these things. I'm always running the same process I teach you. Even after 15 years of A-level teaching, I'm still running the same process. So the key fact here, fact. If you are asked to find an oxy state, everyone else is standard. Okay, so what that now means is I can now break up this compound into its various pieces. So I know that sodium is going to be a +1 ion. It's got to be standard. I know that oxygen will also be standard, group 6, 2-. Therefore, chlorine is now the non-standard. And I have no total charge And that's something which I teach really badly every year. On this compound, there is no overall charge. Yeah, no overall charge. And the reason I know this is because there's no number there. Yeah, no overall charge. If you want to add the 0 in there for your notes, please feel free to do so. But it's nice to realize that that number, of course, just wouldn't exist because it's a 0. So if there's no overall charge, the plus charges must balance the negative charges. So at this point, we can say I've got +1 from sodium. I'm going to add a question mark to it. And I'm going to add to it brackets 2- from oxygen, and it must equal 0. So I'm doing basic algebra here, folks. I'm just going to reorganize this. Just swing this one over to this side. So that's going to be minus brackets 2-. Yeah, I'm going to swing this over to there, which is minus brackets 1+. Yeah, and that all now equals, it all now equals question mark. And I can then run that through my calculator exactly as it is. 0 minus brackets minus 2 close brackets minus brackets +1 close brackets. Oh, darn it. 0 minus brackets 2-. I don't know my calculator, let me do that. Brackets minus brackets +1 equals, and I get a value of +1. Now, can I just point out what a ridiculous process? Can I also mention that my calculator has just spat out the number? The calculator says 1. Yeah, please be careful of this. You must have that charge. You must have the symbol there. I know that seems odd, but you just do. Yeah, they don't make assumptions in chemistry about charges because they have meanings. Yeah. So in this case, the chlorine atom in this case is in a +1 oxidation state. Can I just point out, I don't run this in that way. You can do it that way if you prefer. I'm showing you the maths way of doing this, but I'm just letting you know that I don't tend to do this. I simply say +1 -2. I've got to get to 0. Yeah. And so what I'm doing is I'm looking at the positive and negative charges and realizing I'm going to need another +1 to cancel out the -2. Yeah. I do it that way because it's quicker. Yeah. Because like I said, you can do this. You can do this a whole suite of ways, but as long as you're getting the same answer, I don't care. Let's run another one. And by the way, these are going to get more and more complex as we go through. And we've, as I said, oh, I shouldn't do that. I don't know why I decided to delete all my notes there. I'll keep all of those. Why not even keep the maths bit? Right, let's do question number 2. Right, let's have a go at this guy. Let's make this as difficult as possible. Yeah, brackets, PO42. What is the charge on phosphorus? Go. I'm making this as tough as I can now, folks. Yeah, what is the charge on phosphorus in that compound? Break it into its pieces. This is now about counting particles. Yeah, this isn't really, everyone realizes I pull everyone else out of their standard oxys from the periodic table. I know that calcium is going to be +2, but the key is I have 3 of them. So I'm going to multiply this by 3, which will give me +6. Next, I now need oxygen. How many oxygens do I have? We know that oxygen is O2-, but I have 8 of these. So I'm going to multiply this by 8. So that's going to give me -16. 16-. And the next thing is, right, hang on. So now I realize that there's no overall charge. There's no charge here. It's nice to see answers now coming in. No overall charge. I'm going to give you one of these in a second. No overall charge. So why not just kind of divide this up and go, the negatives need to cancel the positives. Yeah, so I'm going to need +10. But, and this is going to spit out my next rule, but here's the clever bit. There's 2, well done everyone in the class. You smashed it, guys. Divide it by 2 because there are 2 phosphoruses. And the answer was +5. Well done to all of you. Now, at this point, another nota bene makes an appearance. Nota benes from me are important, folks. I promise you that. Yeah, nota bene. You will never see more than plus or minus 7. That is as far as it goes. Yeah? So, and the reason why this nota bene is really handy is because of the plus 10. When I hit plus 10, students will forget to divide by 2. Well, if you have in your head, I can't have more than plus 7, so what's going on here? It means that it'll act as a white flag for reminding you, oh, hang on a sec, if I'm above plus 7, I probably need to divide it by something. How many are there? And it will remind you of this. Yeah, it's a really useful fact to know. Right, can I just say, guys, very impressed. Let's go to the next one. I'm enjoying this game. Fun game. Let's go to the next one. Okay. So let's go for... what shall I do? Oh, yeah, got a good one. Let's go for this guy. Oh, I've got to be really careful here. I'm going to get the formula wrong. Oh, no. Go. Vanadium, please. Right, guys, this one is now going to spit out the wrong answer. Go for it, guys. See if anybody can get the real one, because this one is a trap. As I said, what I'm doing is I'm slowly leveling you guys up. We started off with an easy one, and we're moving up in difficulty. Yeah? And this one's clever. This one's going to cause a couple of people trouble. So what is the charge on vanadium? I'm curious to see if anyone gets this right. Very curious. This is a nice question. I like this question. By the way, this one's come up a fair few times in the last few years. Ooh, Sian saying +4. Interesting. See, Sian's now given a huge hint to everybody. Shaz has given me +4 as well. That's interesting, isn't it? 2 on +4. It's a good sign. So the reason why this one's a trap is because nitrogen is the one that you've got to be wary of here. Now, it's actually in its standard. Yeah, so +4/-4. Oh, it's definitely not both. See, Oliver said +1, definitely not +1. So the clever game here is what we're going to realize is that we have a complex ion here, and you've got to be able to spot these guys. Yeah, we know that ammonium is NH4 plus, and there's 2 of them. What that means is that this must be bringing +2 for that compound. The next thing is we know oxygen is always O2 minus, except in, I'm wrong, calculator error. Yeah, it happens, don't worry about it. So I've also now got -6 from oxygen because there are 3 of them. Yeah, this was times by 2. This one's times by 3. There is no overall charge. Coming to that in a minute. No overall charge. So the positives must cancel the negatives. So do you use complex ions? Yes, you do, Sian. If a complex ion is there, then and they're not asking you about the ion in it, about the atoms in that complex ion, you treat it as the complex. So I had a complex here, didn't I, of the phosphate ion. And I asked you about the phosphorus, which means I could actually have used the complex ion in this particular case and just ignored it and done it as an overall charge of -3, and I would get the same answer. But when I'm in this one, I asked you about an element that was not in the complex. So I will just treat the complex as its complex ion, NH4 plus. I hope that makes sense. It's kind of waffly, that, isn't it? Not very clear. So in this case, I now need to get to 0. So the vanadium must be bringing +4 to cancel out. Now I've got 6 plus in total, 6 minus in total, 0 overall charge. So my answer is 4. Nice and easy. Guys, you're doing really well. Really impressed. Let's go to the next one. Loving this game. See, this is what I mean by I've already taught you guys a lot of this. So let's go to the next one. Let's have a go at this guy. MnO4 minus. I've now given you an ion with an overall charge. My question to you is, what is the charge on manganese? Off you go, folks. What's the charge on manganese? Now I've given you an overall charge. I got nervous about my answer when you said it was a trap. Sorry about that, Shazza. I'll give you a tricky one, a really hard one in a minute. I'll go as hard as we can get. I'm also going to mention an exam question that came up about 6 years ago that completely broke my year 12s. They all got very upset about question. Shazza's saying +7. It's got a big fat question mark next to it. There you go. All of us on the same page as you. It's nice. Doing really well, guys. Nailing this. But I'm confused. Sian, what are you confused about? Give me some details, Sian. The answer is indeed +7. We have O2 minus, it's in its standard, times by 4, minus 8 in total. There is an overall charge, though. Yeah, there's an overall charge. Overall charge of -1. So what that now means is I don't know, the equation just looks weird. Yeah, this is called, by the way, you have to know this guy. This is called the permanganate ion, and yes, it is per, it's a bit weird. Old name. This is called the permanganate. You've got to know that for Edexcel. Permanganate ion. And so let's do the maths. So I've got a question mark plus brackets -8 equals -1. Let's do this algebraically. Always a nice thing to do. Let's now reorganize. Swing that over to this side, so that becomes a minus, brackets 8 minus, yeah, which will then just simply vanish, giving us a question mark. I'll rearrange that to there. I don't like, do you know what? As a teacher, I never like doing that. Plus brackets 8 minus, close brackets equals -1. Right, so now I can reorganize it underneath. So I'm going to move that over to this side, which is to flip that sign there. So this now becomes question mark equals -1 minus brackets 8 minus. Yeah, and then I just run that through my calculator. I'm actually curious to see if my calculator will actually let me do this. -1 minus brackets 8 minus. It's not a syntax error. So the calculator requires you to do the 8 and the minus sign first. If manganate can get +7, why can't carbon get +4? Because this is covalent, Oliver. What did I tell you guys? If you get something of a +4, -4, this is probably not going to be ionic. I'll show you now in a sec. -1, type in this exactly as it is on my calculator, brackets -8. And the answer gives me +7. Winner! Love it. The algebra is quite nice. So just to show you what the manganate ion looks like, manganate looks like this. Mn, double bond O, double bond O, double bond O, bond O minus. Holy moly. Holy moles. Moles, like moles, like 6 point. I'm going to stop because you guys are literally shaking your heads at me, aren't you? And there's the ion. There's what manganate looks like. So the manganese is now covalent, not ionic. But you can treat it as a +7 oxidation state. It's very useful because it actually tells you the number of bonds it's making. How cool is this? Yeah. It's very cool. Yeah. Let's go. So just for those people who are a bit like, whoa, what just happened there with the diagram? Carbon dioxide. Oxidation state of carbon, please. Off you go. Let's see how quick you guys can do this. Go on. First person on the chat. Boom. Spit it out. What's the oxidation state of carbon in CO2? I've lost my marbles. Exactly. +4. Because you just went, O2 minus times by 2. No overall charge. Yep. So that's going to be, oh, sorry, don't like that. No, so 4 minus. Let's do it like the calculator wants it. -4, no overall charge. I must be having +4 on the other side. Nice and easy. Yeah, this is good. So now here's the cool bit. Look at carbon dioxide. How many bonds does it have? It's covalent, not ionic, but you can treat it as +4. Now, Oliver is now going to ask the next question is, why would we do this? The reason why, Oliver, is it's going to allow us to find out if the reactions with carbon are oxidations or reductions. This is cool stuff. Bear with me. Let's do another carbon one just for, giggles. Yeah. What is the oxidation state of carbon in methane? Off you go, folks. You guys are going to be like, what? It's coolest. I love these games. Love these games. And it tells you the number of bonds the covalent compound's making. So cool. Because when you make it actually is, when you should have done bonding. There you go, flipped over, -4. Thank you very much. So, nice and easy. We know that hydrogen is always H+. There are 4 of them, so that means it's +4. Therefore, carbon must be in a -4 to give me no overall charge. How cool is this? Winner! And look at the compound. It's not ionic, but we can treat it as such. Shouldn't the plus be in front, usually? They honestly don't care. Sure, go for it. Put the plus in front, it means the calculator likes it better anyway. But it makes no difference in terms of the chemistry speak if the plus goes before or after, because you're saying it's charged. Like the, what? Shouldn't the plus be in front usually? You can put it wherever you like, I don't care. So these are not ionic compounds. These are covalent compounds, but we can still work out oxidation states of atoms within them based on the standards. The cation in front. Oh, Cyan, you star. I'm really impressed. So you're saying that methane should be written like this. But the great thing is you don't do that because it's not ionic. It's covalent. So the carbon goes first. Carbon always goes first. Yeah, but it's so ugly like that. Oh my God, that's really funny. Only because you're used to it. It's actually, there's something else going on as well, Cyan, which is it's the ability to be able to identify the central atom of a compound within a covalent. It's also useful to do that. You can actually write them the other way around. Like, can you imagine water? Water, that is absolutely fine. That's water. It looks ugly as sin. Or is it an exception for organic molecules? No, because that's non-organic. Yeah, and you know that the H's are the cations in this situation. I hate it. I know. Everyone hates it. And do you know what, Cyan? That tells me I'm doing something good, because it tells me that you guys have picked up a lot of the way that chemistry is being written as a language. Chemistry is a language. I'm teaching you how to speak chemistry. And you know that hydrogen always goes first, and the carbon always goes first, and methane and carbon dioxide. We learn these things as part of the chemistry experience. Oh, it's funny. I was talking about methane. Yeah. Anyway, so at this point, I think everyone, I'm just going to give you one more, guys. I'm going to make this, let's make it as hard as possible. What do I want to give you? Oh, I've got to mention a question now in an exam. So this question was on an AS paper about 7 years ago, 6 or 7 years ago, and they gave this. FE304. My question to you is, and by the way, the question was very straightforward. It simply said, chem rules feel like English. There is a rule, and then here are the exceptions. Yes, Oliver, yes. You learn the basic rules at GCSE, and then you learn the exceptions when you get to A-level. Yes, correct. In reality, though, once you understand the rules, all you have to then do is learn the exceptions, and you're done. Build chemistry. You always build chemistry. So the question is, iron. Off you go. What is the oxidation state of iron in that compound? My kids did not like this one bit. Oh, it's the different Fe thing. Nice one, Cyan. Yes, it is. The students did not, what light. So can I just point out, this was an absolute nightmare, this. The question on the paper said, calculate iron oxy state. That's all it said. And on the mark scheme, O2 minus times by 4 minus 8. Iron, no overall charge, plus 8, divide by 3. Final answer, 8 divided by 3. The answer on the mark scheme was 2.66 or 2.67. However, yeah, it also, that was the number one answer. Yeah, but it also said in the column, allow plus 2 and plus 3 together. Yeah, you weren't allowed to put them independently. You couldn't put, it said do not allow, yeah, don't allow plus 2 only or plus 3 only. That's what it said on the mark scheme. Yeah. The following question then said, following question after that, suggest how this compound exists. God, the kids hated this. As soon as you see the word suggest, everyone freaks out. We know this. It's part and parcel like chemistry. Part and parcel of all science. They say suggest. You're having to use a bit of, you're having to think about it. Yeah, it means that you probably haven't been taught it. And all you had to say is, answer on the mark scheme, ions exist as iron 2 plus and iron 3 plus. 1 mark. Second mark. There is a mix of the two. Mix of the two ions. They could, and it's actually really nice. Cyan's actually done something really clever, which is technically, you could have actually given the ratio. You could actually say that there are 2 iron 3 pluses for every 1 iron 2 plus. Yeah, because that would give us the 8. Yeah, does that make sense? There must be more 3 plus than 2 plus because we're closer to the 3 than we are because it's 2.667 or 2.67. The 6 is closer to the 3, so there must be more 3s than 2s. Yeah? But that was the answer. 2 marks, really good question, but students really, really hated it, didn't like it at all. Freaked everyone out. These are actually given a very specific name. I can't remember for the life of me what that name's called. It's a certain type of ionic compound where you have a mixture of charged of ions in different oxidation states of the same one. They're given a name. I can't remember what it's called. My dad mentioned it not so long ago. Right. So at this point, I can go back to my learning objectives. We can definitely all now do this. Right. Reduction and oxidation rules. I've only got 5 minutes left. I'm very aware of this. Okay. Do you know what? I'm actually going to leave it here today, folks. I'm actually going to leave it here. I will also, I'm going to leave it there. There's no point in me doing the last 5 minutes and rushing it because I want to do the oxidation reduction in regards to this, and I know that there's a lot to do. So what I'm going to do, I'm going to post you guys your homework on the classroom, and it's just a whole list of these questions. Yeah, like 2 pages of, here's the compound, give the oxidation state of X. Yeah, and I'll post that on the classroom in a moment, and you guys can crack on with that. The homework is due for next lesson. It shouldn't take you very long. Yeah, it really won't. Guys, if you need any help, give me a shout out on Google Hangouts at any time. Guys, have a nice rest of your day, and I'll see you all tomorrow. See you guys.